Here we are on page 19 and 20 of differentiation. We're going to do the odds on this page. Find the coordinates of the local maximum or local minimum point for each quadratic curve. State the nature of this point. You can use differentiation to find this point, and I'll do the first one like that. But the others I'll just use the minimum and maximum function on your calculator because that's more likely what you would do on the exam. So for number one, we have this quadratic. And they're saying, where are the maximums and minimums? Well, remember, maximum and minimums of a function can be found by taking the derivative. When the derivative or the gradient function is equal to 0, that is a maximum or minimum point. Okay, and then if you want to find the maximum or minimum point or the derivative here, you would say the derivative of this is equal to 2x minus 4, right? And then you would say, okay, when is this equal to 0? And then you say, well, this is equal to 0 when, and you would add 4 to both sides. And you would say it's 2x equals 4, x equals 2. So there is a max or a min at x equals 2. And they asked for the coordinates of the point. So then you would have to take x equals 2 and you would put it back in here. So that would give you y equals 2 squared minus 4 times 2 plus 10, which is equal to 4 minus 8 plus 10, which is equal to 6. Okay, so the coordinate would be 2 comma 6. Make sure you don't put the 2 back in the derivative because you're just going to get 0 again, of course. So to find the first answer, which is what's the coordinate, you do it like that. And then state the nature of this point. You can find if it's a maximum or a minimum by looking at the gradient to the left and to the right. Okay, now I'll show you how to use it to do it on the calculator. You just put the function in the y equals screen, and then you graph it. And there we have our quadratic. And then we want, obviously there's a minimum here and there's no maximum that we can see. To find this point here, you would do second calc, minimum, and then you would say, well, the left boundary could be here, and the right boundary would be on the right side of the valley. And so we could use that for our guess. And the answer is x equals 2, y equals 6. Hey, what do you know? That's the same thing. Okay, so the coordinate, which is the minimum, is going to be 2 comma 6. And when you notice it says 2.000016, when you round it to 3 significant figures, you're going to get x equals 2. The reason why it doesn't come out to a perfectly whole number is because the calculator uses an approximation, and so it doesn't exactly get to the exact answer. Okay? All right, now let's do number 3. And I'm just going to do this with the calculator, okay? So we have y equals x squared plus x minus 3. We're going to program it in the calculator. So here I've programmed it in the calculator, then I graph it. Okay, and there is a minimum point, so we know it's a minimum. We'll do second calc minimum, which is number 3. And we'll say the left bound, we need to move the cursor to the left side of the minimum. Then we move the cursor to the right side of the minimum. And then we guess. And it tells us that the minimum is at negative 0.5, comma, negative 3.25. Okay, so that was number 3. Now we'll do number 5. So we're going to put this one in the calculator. So here we have 3x plus 11 minus x squared. We graph it. Ooh, it's a maximum this time. Then we do a second calc maximum, which is 4. Left bound is fine there. Then we go to the right side of the maximum and we hit enter again. And we can hit enter for guess. And the maximum is 1.5 comma 13 point. See, 1.5 comma 13.25. And this is a maximum. Okay, and then number 7. Number 7 is a factored quadratic. We can put it in the calculator right the exact same way. You don't need to do FOIL or anything to put it in the calculator. The calculator doesn't mind that it's not multiplied out or simplified. X minus 3, x minus 7. Graph it. And then there's obviously a minimum here, so we do second calc, minimum, left bound, we go, oh, that's fine, that's way left. And then we go a little bit to the right of the minimum, hit enter, guess. Okay, so this is going to be a minimum, and it's 5, comma, negative 4. And last of all, we're going to do 9. Again, 9 is not multiplied out, but that's fine. We're going to put x times x plus 4. X times x plus 4. Graph it. It's a minimum, isn't it? It's a minimum right there. Second calc, minimum number 3. With left bound, we go a little bit to the left of the minimum. Enter. And then right bound, we go a little bit to the right of the minimum. Hit enter. Then we just hit guess. And it's a minimum. And it's at negative 2, comma, negative 4. Okay? All right. Now we're going to section 6 now. These are word problems. And it's the first page is to get used to taking 2 equations with 2 unknowns and turning it into 1 equation with 1 unknown. Once you get a word problem so that it's 1 equation and 1 unknown, then it's ready to be optimized, or you're ready to take the derivative to find the optimization. When you have two unknowns, you can't do that yet. And you'll see how that works later. But on this first page, all we're doing is eliminating one of the 2 unknowns. So here we have this equation, and we have this equation, and they both have the unknowns b and h. Okay? What we want to do is we want to get one equation with 1 unknown, and then we're going to eventually use that to find the optimum solution. You use this in problems where you say something like, you have a certain amount of fence, and you would like to enclose the largest amount of area with this amount of fence. In this case, let's see, we don't actually know what's going on, but it looks like an area equation, and then the difference between the 2 sides of the rectangle is 7. Okay, so use the constraint, and this is the constraint here, to express b in terms of h. So b in terms of h means you're going to have b equals something, something, something with h in it. Okay? Doesn't matter how it looks as long as there's only h in terms of variables there. So we're going to take the constraint equation. How do we make it so that b is on the left by itself? We're going to add h to both sides. That will get b by itself. So this would be b, and the right side is going to be 7 plus h. Okay, so that's the answer for part A. And that's the first step to making an area equation with only one variable. B, it says express A in terms of h. So we have A equals BH. A is in terms of B, and it's in terms of h also. We need to get it so this is in terms of only one variable, and it says to have that variable BH. Not BH, but BEH. Okay? So we leave, or we're going to take b here. Instead of b, we're going to put 7 plus h. Okay? So we're going to 7 plus h. And that's going to be multiplied times h. Okay? So now we've rewritten a so that it only has the variable h in it, no more variable b. And so now we can either leave it like that, or we can multiply it out and get 7h plus h squared. Okay? So that would be the answer to part B. Now 3, 5, 7, we're going to be doing similar things. So p equals x squared times y is subject to the constraint 2x plus y equals 5. Use the constraint to express y in terms of x. Okay, so let's see. How do we get y by itself on the left side? We would subtract 2x from both sides. So subtract 2x from this side, we get rid of 2x, and then subtract 2x from the right side, and then we'll have 5 minus 2x, and we're done. So that is the answer for A. Express p in terms of x. Well, right now we have p in terms of x and in terms of y, but it says to express it in terms of x only. So the x we can keep, and then we need to substitute into y something that has x's in it. Hey, how convenient, we have it right here. So we're going to substitute 5 minus 2x in for y, and we are basically done here. Okay, this is the answer. We can simplify it or multiply it out, but we don't have to. 5. L equals 2m times m quantity x, m plus x, subject to the constraint, and that's kind of a messy one. Express L in terms of m. Okay, now they skipped something, because usually in the first 3 problems they told us, or the first 2 problems they told us that we were supposed to find y in terms of x, etc. So to get L in terms of only m's, look what we have here. We have an x here. We need to get rid of the x, so we need to substitute something in for x. Here we have a relationship between x and m. So if we wrote x equals something, 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 m, then we could substitute that in and we'll solve our problem. So what we're going to do is we're going to try to solve for this. We're going to put x by itself on the left. But it's kind of hard to, because we got all this multiplication and PEMDAS stuff going on. How are we going to do that? Okay, first step. Well, look how x is buried in all these operations. Let's get rid of the outside operation, which is a half. How do we get rid of a half? We're going to multiply both sides by 2. And then this will be x plus 5m equals 50 times 2, which is 100. And then we're going to solve for x. So it's going to be x equals 100 minus 5m. Okay? And so then we can plug the x into here, and we'll have L equals 2m times m plus 100 minus 5m. Okay, and then we can simplify this. 2m times m plus 100 minus 5m. M minus 5m is equal to minus 4m, right? So that would be 2m times 100 minus 4m. Okay? So that's what L is in terms of m. Then it turns around and says express L in terms of x. Oh man, okay. So now we need to get rid of the m's. How do we get rid of the m's? Well, we're going to write an expression like this. Instead of having x on the left, we're going to have m on the left. How do we do that? Okay, again, we start with the same equation, x plus 5m equals 50, and we need to get m by itself. So we need to first multiply both sides by 2, and we get 100 here, and we get x plus 5m, and we want to get m by itself, so let's subtract x from both sides, and we'll have 5m equals 100 minus x. And then we're going to divide both sides by 5. And we're going to have m equals 100 minus x divided by 5. Okay, and that is what we need to put in the original L equation. Let's see, L equals 2m times m plus x. So the m here, 100 minus x divided by 5, we're going to put it in 2 places. We're going to put it here, 100 minus x divided by 5. And we're also going to put it here, 100 minus x divided by 5 plus x. Okay, and then we're done. And that's all they asked us to do. We could simplify it, but not necessary. Okay, last one for this section. Y equals 5x squared plus c, 12x minus 2c equals 3. Express y in terms of x. Okay, so the only problem is with like this equation here is that it has a c in it too. We got to get rid of the c. So to get rid of the c, we're going to use the constraint equation, and we're going to solve for c. So let's see, 12x minus 2c equals 3. How about, so what we want to end up with is like c equals something, something, something with x in it. All right? So to do that, we will put 2c on one side, and on the other side we'll have 12x minus 3. Okay, the way we do that is we add 2c here, add 2c here, subtract 3 here, subtract 3 here, and then we end up with this, 2c equals 12x minus 3. And then we divide both sides by 2. Divide this by 2, divide this by 2, we get c equals 6x minus 3 halves. Okay, so 3 halves is 1.5, right? So I'll just write 1.5. So now we have an expression where c equals something, something x. That's exactly what we wanted. Now we're going to substitute that in to the y equation. So we have y equals 5x squared plus 6x minus 1.5, which is c. So now we've succeeded with part A. Then part B, use differentiation to find dy dx. So that would be part B. Y prime is equal to derivative of 5x squared is 10x. The derivative of 6x is 6. Derivative of negative 1.5 is 0. Okay, so now we've already found dy dx. Hence, find the minimum value of y. Okay, so they're saying that there is a gradient of 0 at some point for this equation. So what we can do is we could say, hey, y prime is equal to 10x plus 6 equals 0. And then we could say that, hey, 10x, we can subtract 6 from both sides. We're going to get 10x equals negative 6, x equals negative 6/10, or equal to negative 0.6. Okay, so that is the answer to C. Minimum value of y. They asked for the minimum value of y. We found the value of x that makes y a minimum. So what we're going to do now is we're going to put it back into the equation. Y equals 5x squared plus 6x minus 1.5. We're going to put negative 0.6 in there. And that's going to give us the minimum value of y. Okay? The other way we could do that, which is probably easier, is we can do what we did earlier, and we can put both of the equations, the original, if we put the function and its derivative in the calculator, we can figure out the minimum value of y more easily. So let's graph these, and we should get a parabola and a straight line. Okay, and then we can look at the table, and this should answer one of the questions. Oops, and look what I did. The table is counting by 0.1s. I'm going to change that to just 1 by doing plus 1 there. Okay, and then let's see. One of the things we want to know is when the gradient is equal to 0, and we found that that was at negative 0.6. Looks like it would be around negative 0.6, right? But it's between negative 1 and 0. If we want to see it exactly, what we could do is we could do plus 0.1. And then we could see at negative 0.6 that the gradient is 0. Okay? And then at negative 0.6, what's the y value? It's negative 3.3. So instead of like substituting into this equation, x equals negative 0.6, what we can do is just look at the calculator, and then it's going to be negative 3.3. Okay, that was C. Now finally D, the last part. Find the value of C that corresponds to this minimum value. Okay, let's see. We know that C is equal to 6x minus 1.5. So that means that if we know that x equals negative 0.6, then this would be 6 times negative 0.6 minus 1.5, which is going to be equal to negative 3.6 minus 1.5, which is equal to something like negative 5.1. Okay? And that's it for this section.